In our daily lives, the numerical information are everywhere. That's why it is so important for us to learn about statistics, because the knowledge of statistical methods will help you understand how decisions are made and give you a better understanding of how they affect you. Because no matter what in your career, you will make professional decisions that involve data. And an understanding of statistical methods will help you make this decision more effectively. Statistics has a much broader meaning than just collecting and publishing numerical information. We define statistics as the science of collecting, organizing, presenting, analyzing, and interpreting data to assist in making more effective decisions. There are two types of statistics. It's descriptive statistics and inferential statistics. Descriptive statistics are the methods of organizing, summarizing, and presenting data in an informative way. While the inferential statistics are the methods used to estimate a property of a population on the basis of a sample. And there are two types of variables. The first variable is qualitative and the second variable is quantitative. When the characteristic being studied is non-numeric, it is called a qualitative variable. Examples of qualitative variables are gender and eye color, car brands. When the variable studied can be reported numerically, the variable is called a quantitative variable. Examples of quantitative variables are the balance in your account and the number of children in a family, the ages of company presidents. And that's a quick explanation about statistics, but actually the main concern of this video is the levels of measurement. In the levels of measurement, the data can be classified according to the levels of measurement. The level of measurement of the data dictates the calculations that can be done to summarize and present the data. When we talk about levels of measurement, we're talking about how each variable is measured and the mathematical nature of the values assigned to each variable. This in turn determines what type of analysis can be carried out. The four measurement levels, in order from the lowest level of information to the highest level of information. The first one is nominal level data, and ordinal level data, interval level data, ratio level data. And these four level data divided into two, where the nominal and ordinal level data are qualitative and the interval and ratio level data are quantitative. We begin with the nominal level data. For the nominal level of measurement, observation of qualitative variable can only be classified and counted. There is no particular order to the labels and contain the least amount of information. They are purely descriptive, they don't have any quantitative or numeric value, and the various categories cannot be placed into any kind of meaningful order or hierarchy. Nominal data is the simplest, least precise level of measurement. For an example of the nominal level data is based on the data from this link, www.nhs.int nhs.uk. That said, there are four main blood groups, or we can say types of blood. There are A, B, AB, and O. And each group can be either Rhd positive or Rhd negative, which mean in total there are 8 blood groups. So there are A minus, A plus, B minus, B plus, O minus, O plus, and AB plus, and AB minus. And that's a simple example of the nominal level data. Based on the example, you can identify that no particular order to the levels, don't have any quantitative or numeric value, no one category is greater than or worth more than another. Next is the ordinal level data. Ordinal level data is a type of qualitative non-numeric data that groups variables into descriptive categories. A distinguishing feature of ordinal level data is that the categories it uses are ordered on some kind of hierarchical scale, like from high to low. These are still qualitative labels, as with the nominal scale, but you can see that they follow a hierarchical order, and it classifies the data while introducing an order or ranking. On the levels of measurement, ordinal data comes second in complexity, directly after nominal data. For an example of the ordinal level data, based on this link, mwcc.edu. Let's say the level of difficulty is very difficult, difficult, neutral, easy, and very easy. Based on the example, you can identify nominal data are categorical, non-numeric, but may use numbers as labels. Ordinal data are always placed into some kind of hierarchy or order. While ordinal data are always ranked, the values do not have an even distribution. Next is the interval level data. Interval data is a type of quantitative numerical data. A numerical scale which labels and orders variables with a known, evenly spaced interval between each of the values. Interval data is all about measuring variables on an equidistant scale, where the 0 point is an arbitrary figure. For an example of the interval level data based on this link, web.ngit.edu, that show the list Celsius in Fahrenheit in temperate range from 0 degree Fahrenheit until 104 degree Fahrenheit, and from minus 17.8 degrees Celsius until 40 degrees Celsius. Temperature in Fahrenheit or Celsius can be an example of the interval level data. For example, 20 degrees Celsius is colder than 25 degrees Celsius, and the temperature difference is the same as the difference between 30 degrees Celsius and 35 degrees Celsius. In other words, the difference of 5 degrees Celsius in both intervals shares the same interpretation and meaning. So, based on the example, you can identify nominal data according to the following characteristics. Interval data measure using continuous intervals that show order, direction, and a consistent difference in values. The difference between values on an interval scale is always evenly distributed. Interval datasets have no true zero. They may contain negative values. This means they can be subtracted and added, but when multiplied or divided, do not offer meaningful insights. Next is the ratio level data. Ratio data classifies and ranks data and uses measured continuous intervals, just like interval data. However, unlike in interval data, ratio data has a true zero. This basically means that zero is an absolute, below which there are no meaningful values. Speed, age, or weight are all excellent examples since none can have a negative value. You cannot be minus 10 years old or weigh minus 160 pounds. For an example of the ratio level data based on this link, www.preaching.com. Let's show a survey of how much time each day do you spend on social media, and the possible answer are never. Less than 15 minutes, 50 till 30 minutes, 30 minutes till 1 hour till 2 hours, and 2 hour or more hours. Note that in this example, the distance between intervals is always equal and there is a true zero, which is the possible answer of never, because you cannot spend minus 2 hours a day on social media. So, based on the example, you can identify the ratio level data are measured using a continuous, equidistant scale that shows order, direction, and a precise difference in values. Ratio data have a true zero. Zero represents an absence of the variable, and you cannot have negative values. Because ratio data lack negative values, they can be added, subtracted, multiplied, and divided, unlike the other three types of data. That's all for the levels of measurement. Thank you.